In this video, we're going to look at our test review on the unit on graphing polynomials. In these first four questions, we've got some graphs of different polynomials that we need to match with an equation. So in question number one, looking at that graph, the first thing that I notice is that both ends of the graph are going up, and that means that the degree of this polynomial should be even. And also, since they're both going up, I need to have a positive leading term. The other thing I want to do here is count the number of turning points. I've got 1, 2, 3 turning points, and that means that my degree is going to be 4. I'm going to have a degree of 4, and so I need to have a positive leading term with a degree of 4, and that matches answer choice E. And so question number one is E. All right, let's look at number two. Again, I'm going to start with the end behavior, and this end is going down, the other end is going up. My ends are going in opposite directions, and so that means that I should have an odd degree on this one. Sorry, you can't read that. Try that again. We're starting at negative infinity and ending at positive infinity, and so this is a positive graph. Overall, the graph is going up. And then if I count turning points, I've got one here and I've got one here. So there's 2 turning points, which means I should have a degree of 3, which is indeed an odd number. And so if I look at my answer choices, degree of 3 and positive leading term, that matches answer choice C. All right, next, number 3. This one should be pretty easy because we're pretty familiar with parabolas, but let's talk about it as a polynomial. My 2 ends, they're both going up. They're in the same direction, which means the degree is even. And it's opening up, and so that, of course, means that it's positive, and there's only one turning point, which indicates a degree of 2. And so this matches with answer choice A. And finally, our last graph down here, if I look at the end behavior, the 2 ends, they're going in opposite directions. And so that means that I should have an odd degree. Overall, this function is going down. We're starting at positive infinity and we're ending at negative infinity. So that means that I should have a negative leading term. And then I want to count my turning points. And I've got 1, 2, 3, 4 turning points, and so that indicates a degree of 5. So I'm looking for a degree of 5 with a negative leading term, and that corresponds to answer H. All right, let's move on to the next set of graphs. In this set of graphs, if you look at our answer choices here, we're really testing our understanding of what happens whenever we have a factor that's squared or when we have a factor that's cubed, how those kinds of things affect our graph. So let's look at question number 5. We'll start there. And the first thing that I want to do on these is identify what my zeros are. Where is the graph intersecting the x-axis? Well, on this graph, that happens here at -2, and then also here at +1. So if my zeros are -2 and +1, then that -2, if I write that as a factor, that would be x plus 2. And I need to write these as factors because if you look at our answer choices, they're all in factored form. So whatever my zeros are, I need to turn them into a factor. And since my 0 is at -2, if I plug in -2 for x, -2 plus 2 would be 0, and that would make the polynomial 0. So the factor is x plus 2. And my other factor, if the 0 is 1, that factor would be x minus 1. And those are my only 2 zeros, so those should be my 2 factors. However, if you notice here at -2, my graph is not crossing the axis. It's coming up, touching, and then it's turning back around, making like a little parabola there at -2. And remember, that means that -2 is a double root. That factor should be squared. And so if I look at my answer choices over here, I see x plus 2 squared and x minus 1. Right here, answer C. Now another thing we could have thought about here, notice that this graph is a cubic graph. I am looking for a degree of 3, and you might be able to narrow down your answer choices by just figuring out the degree of the polynomial. Let's move on to question number 6. Again, I have a degree of 3 here. Go ahead and write that down. And let's find our zeros. Right here at negative 2. There's 1 here at 0 and at positive 1. So those are my 3 zeros. I need to turn those into factors. Again, if negative 2 is a 0, then that factor would be x plus 2. If 0 is a 0, remember that the way we write that factor is just with an x. And then if 1 is a 0, x minus 1 would be a factor. And so if I look at that, if I multiplied all my first terms, I would end up with x cubed, which is a degree of 3. And so it looks like that's probably my answer. And also if I check out all the zeros again, notice that the graph is crossing the axis at each one of these zeros. We're crossing, not doing anything different, and so we don't have any double roots or triple roots. And so if I go over to my answer choices, it looks like this one matches answer A. All right, question number 7. On this graph, looks like here we have a degree of 4. So I'm looking for, whoops, sorry about that. I'm looking for factors that would multiply out to give me a degree of 4. If I identify my zeros, I've only got 2 zeros. Now if I have a degree of 4, I should have 4 zeros, but I've only got 2 here. And so that means that I've definitely got maybe a double or triple root. Well, I've got a 0 here at negative 1 and a 0 at positive 2. So if I rewrite negative 1 as a factor, that would be x plus 1. And if I rewrite positive 2 as a factor, that would be x minus 2. Now if I look at the graph here at negative 1, notice that it's coming down, touching, and turning back around, making like a little parabola sitting on the x-axis, and that means that is a double root. So I'm going to square x plus 1. And then the same thing's happening over here at 2. Graph is turning around, making a little parabola, and so that root is also a double root. And so if we look at our answer choices, it looks like our answer here matches choice E. All right, last question, number 8. So this graph here is we've got a degree of 5 here. But again, I've only got 2 zeros. 2 zeros. One of them over here at negative 1, one here at positive 2. If I rewrite negative 1 as a factor, that would be x plus 1. And if I write 2 as a factor, it's x minus 2. So I need to have a power of 5. Right now, I've only got x times x. I've only got a degree of 2. So we must have, these are multiple roots. Let's look back at negative 1. Notice at negative 1, the graph comes down and flattens out and then continues, making what looks like a cubic shape right there at negative 1, which means that this x plus 1 factor is going to be a triple factor. Negative 1 is a triple root. Over at positive 2, again, the graph comes up, touches the axis, and turns back around, making a little parabola. And so 2 would be a double root. X minus 2 is squared. Now also notice, probably should have paid attention to this before we did all of that work, notice that our end behavior, we're starting at positive and ending at a negative. This graph, this polynomial, should be negative. And if we realize that, we're actually narrowed down to only choices G and H. Those are the only ones that have the negative sign there. And if you notice, answer choice G matches our work. All right, let's move on to the next question. On 9 and 10, we're asked to solve these inequalities. First one here, 2x squared minus 5x greater than or equal to 3. Remember, on these inequalities, the first thing we want to do is get everything on one side of the equation and have it equal to 0. So I'm going to move the 3 over to the other side. And I have a quadratic here I need to factor. So I'm going to multiply my first and last terms to get negative 6x squared. And so I need factors of negative 6x squared that would add or subtract to give me negative 5x. And in fact, in this case, it's important to notice that this is negative, which means that I need to have different signs in the factors that I choose. I need to subtract those two numbers to get negative 5. And that's important because if I list the factors of 6x squared, that'd be 6x and 1x, but also 2x and 3x. Both sets of those factors will actually give you 5, but we have to pick the 6x and the 1x because we need to subtract to get the 5. So I'm going to have a negative 6x and a positive 1x. So I'm going to go back over here and rewrite my quadratic, and instead of putting negative 5x, I'm going to put negative 6x plus 1x, and then minus 3 at the end, greater than or equal to 0. All right, so now I'm going to factor by grouping. I'm going to group my first two terms together. I can factor out a 2x, and I have left x minus 3. In my second two terms, the only common factor is 1, so I'm going to put plus 1, and I'm left with x minus 3. Notice that my two parentheses came out the same. That should always happen if the quadratic is factorable. And so now I'm going to factor out the x minus 3, and I'm left with 2x plus 1. Now I want to know when this is going to be greater than 0. I know that this is going to be equal to 0 at positive 3, because 3 would make x minus 3 be 0. And then my other 0 would be negative 1/2. Negative 1/2 would make the 2x plus 1 equal to 0. So now it's time to do our sign chart. We're looking for where this is greater than or equal to 0. That means that I want to know where this polynomial is positive. Greater than or equal to 0 means positive. So we're going to do the sign chart. So I'm going to draw my number line down here at the bottom. Negative infinity, and then let's see, there's negative 1/2, and then 3, and then of course this would go to positive infinity. And I'm going to go ahead and make the chart. If you can do this without drawing the whole chart, that's great. I'm going to list my factors here, x minus 3, 2x plus 1, and I'm going to pick numbers in these interval. These are going to be my choices up here. So in my first interval between negative infinity and negative 1/2, I'm going to choose the number negative 2. That's definitely in that interval. If I plug in negative 2 to x minus 3, I'm going to get a negative value because negative 2 minus 3 would be negative 5. And if I plug negative 2 into 2x plus 1, that would be negative 4 plus 1, which is going to come out negative. And if I multiply a negative times a negative, that's going to equal a positive for that interval. Let's try the next interval. Between negative 1/2 and 3, I'm going to choose 0. Because 0 is definitely between those two values. If I plug in 0 into x minus 3, I get a negative value. If I plug 0 into 2x plus 1, then it's positive. And a negative times a positive equals a negative. Last interval from 3 to infinity, I'm going to pick the number 5. If I plug 5 into x minus 3, I'm going to end up with a positive value. And if I plug in 5 into the 2x plus 1, again, that's going to give me a positive value. And positive times a positive would be positive. Now remember, we are looking for where this polynomial is greater than or equal to 0, or where it's positive. And so you can see that I'm going to choose this interval and this interval. So my answer would be negative infinity, notice with the parentheses. Anytime you're writing infinities, it's going to be a parentheses. Negative infinity to negative 1/2. And since the inequality is greater than or equal to, then we're going to use a bracket on the negative 1/2. And then in our other interval, it starts at 3 with a bracket and goes to infinity with a parentheses. Let's move on to the next question. Again, we've got another inequality here. We're going to get everything on one side. 9x squared minus 16 less than 0. And to factor this is just a difference of two squares. So that's going to be 3x plus 4 and, whoa, okay, I'm having a little technical difficulty here. There we go. 3x minus 4. That's our factored version. So I need to determine what my zeros are here. My zeros would be negative 4/3 and positive 4/3. So now we're ready to make our chart. So I'm going to draw my number line down here from negative infinity, negative 4/3, positive 4/3 to infinity. And I'm going to list my factors over here on the side. 3x plus 4 and 3x minus 4. And so now we're going to pick numbers that are in these intervals. Be careful with fractions. I think sometimes we tend to make mistakes about the value of what a fraction is and what numbers are bigger or smaller. If I'm looking for something between negative infinity and negative 4/3, I mean, we could pick negative 3, negative 2 even, but if you're not sure, you could pick a number as big as negative 10, just to make it easier on yourself to figure out. I'm going to pick negative 4. Negative 4 is definitely in that interval. If I plug negative 4 into 3x plus 4, I would get negative 12 plus 4, which is definitely negative. And if I plug negative 4 into 3x minus 4, I get negative 12 minus 4, which again is negative. And then if I multiply a negative times a negative, that's going to give me a positive. In the next interval, between negative 4/3 and 4/3, I'm going to pick 0. If I plug in 0 to 3x plus 4, that's going to give me a positive value. And if I plug 0 into 3x minus 4, I'm going to end up with a negative value. And positive times negative is negative. Final interval, some number between 4/3 and infinity. I'll just choose positive 4. If I plug positive 4 into 3x plus 4, that comes out positive. If I plug positive 4 into 3x minus 4, that's also positive. And a positive times a positive equals a positive. Now remember, let's go back and look at our inequality. We wanted to find out where this polynomial is less than 0. Less than 0 means that we're looking for where it's negative. So that, of course, is right here in the middle interval. So it's going to be negative 4/3 to 4/3. And notice that the inequality does not include or equal to. It's just less than. And so we're not going to include those numbers. We're going to use parentheses for our interval. All right, question number 11. We're sketching the graph of a polynomial here from the factored form. So if I look at the factored form of this polynomial, first off, I notice there's a negative sign here. And so my graph should be going down. If I think about my first terms here, I've got x minus 2 cubed, and so that first term would be x cubed, and then x plus 3 squared, that first term would be x squared. And so this is giving me an x to the 5th polynomial, a power of 5 polynomial. And we want it to be negative. We want it to be going down. So if I've got a power of 5, I should have 4 turning points going down. So let's see, 1, 2, 3, 4. There we go. Basic shape of the graph. Now my zeros, since there's only 2 factors there, there's only 2 zeros. My zeros are 2 and negative 3. But remember that 2 is a triple root because that factor is cubed. And then negative 3, that's going to be a double root because that factor is squared. So let's see if we can sketch this graph. I'm going to mark, oh no, it's not negative 2, it's negative 3 and positive 2. And negative 3 is a double root. So I'm starting, remember our graph is going negative, so I'm going to start up here at the positive, and I'm going to come down to negative 3, and it's a double root, so it's going to make a parabola, touch the axis and turn back around. And then we're going to go up and come back down. At 2, it's a triple root, so we need to make a little cubic graph going through at 2. And there is our power of 5, negative power of 5 graph. All right, last question, and this is, what the whole unit was about, is being able to complete a problem like this without the calculator. So first off, let's figure out the basic shape of the graph. I notice that my leading term is positive, and it's a degree 4. And so I need to, both ends are going to be going in the same direction, since 4 is an even number, and they're both going to be going up, since the term is positive. I should have 3 turning points. And so this is the W graph, as we like to call it in class. It should look something like this when we get finished. My y-intercept, that's 4. My possible rational roots. Remember, to get the rational roots, it's going to be the factors of the constant term, which in this case is 4, over the factors of the leading coefficient, which here that number is 2. So my factors of 4 are 1, 2, and 4. And then the factors of 2 are 1 and 2. So my possible rational roots would be all the possible fractions or rational numbers that I could make out of those factors. So we are going to consider plus or minus, could be positive or negative, 1 over 1, 1 over 2, 2 over 1, 2 over 2, 4 over 1, and 4 over 2. Those are all of my possibilities. I should end up with 4 factors and 4 zeros because I have a power of 4 graph. And so that means I need to find 2 of these by doing synthetic division. So I'm going to write down my coefficients. Let's see, let's get down here a little bit. Actually, you know what? I'm going to do synthetic division on the next screen. Make sure I have space for that. So my coefficients are 2, negative 5, negative 3, 8, and 4. And I'm going to pick, I'm going to try 2 to start with. So let's see, I'm going to bring down the 2. 2 times 2 is 4. Negative 5 plus 4 is negative 1. 2 times negative 1 is negative 2. Negative 3 plus negative 2 is negative 5. 2 times negative 5 is negative 10. 8 plus negative 10 is negative 2. And 2 times negative 2 is negative 4. 4 plus negative 4 is 0. Excellent. So I have now determined that 2 is a 0 of this polynomial. So I'm going to go back over here, and where it says zeros, I'm going to add 2, and that means that in my factored form, I'm going to have the factor x minus 2. If the 0 is positive 2, then the factor is x minus 2. All right, let's go back and find another one. Now remember, once we found 1, 0, as I keep going and trying new roots, I'm going to use the new coefficients. So for my next synthetic division, I'm going to use 2, negative 1, negative 5, and negative 2. And this time let's try 1. So I'm going to bring down the 2. 1 times 2 is 2. Negative 1 plus 2 is 1. 1 times 1 is 1. Negative 5 plus 1 is negative 4. and 1 times negative 4 is negative 4, and I get negative 6. So 1 is not a 0. But an interesting fact here, on my parabola, I'm going to have the point 1, negative 6. That's going to be a point on the parabola. You don't have to graph that, you don't have to think about it, but it's just interesting to note that at this point. So let's try negative 1 instead. Again with 2, negative 1, negative 5, negative 2. So I'm going to bring down the 2. Negative 1 times 2 is negative 2. Negative 1 plus negative 2 is negative 3. Negative 1 times negative 3 is positive 3. Negative 5 plus 3 is negative 2. Negative 1 times negative 2 is positive 2. And excellent, I got another 0. Negative 1 is a 0. So when I go back over here, let me see, I'm going to pick a different color to write this. I'm going to list negative 1 as the 0. The corresponding factor would be x plus 1. All right, so now I've got 2 factors, 2 zeros. I know that I need 4, but now that I've found 2 with synthetic division, I'm down to a quadratic that I can factor. These coefficients here are going to give me the quadratic 2x squared minus 3x minus 2. So let me write that again over here. 2x squared minus 3x minus 2. So we need to factor this. First thing I'm going to do is multiply my first and last term. And if I do that, I get negative 4x squared. So I'm looking for factors of 4x squared that are going to add or subtract to give me negative 3x. And in this case, since it's negative, we want to subtract. So that would be 4x and 1x. And if I'm going to get negative 3 and the x in the middle, I need a negative 4x and a positive 1x. So I'm going to rewrite my quadratic as negative 2x squared minus 4x plus 1x minus 2. And now we're ready to factor by grouping. From this first group, I can factor out a 2x, and I'm left with x minus 2. And in the second group, there's no common factor other than 1, so I'm going to put a plus 1, and then again I'm left with x minus 2. My parentheses came out the same, and so I'm going to go ahead and factor that out. I'm going to factor out the x minus 2, and I'm left with 2x plus 1 in the other parentheses. So now I have my last 2 factors. So I'm going to add these to my factoring. Choose a different color for that. X minus 2 times 2x plus 1. So those are my 4 factors, but I still need 2 more zeros. If I look at x minus 2, that 0 is positive 2, which we already have listed. So that means that positive 2 is going to be a double root. And then if I consider 2x plus 1, the 0 that comes from that factor would be negative 1/2. Now notice I've got x minus 2 as a factor listed twice, and you could certainly rewrite this whole thing. You could rewrite it as x minus 2 squared, indicating that double root, times x plus 1 times 2x plus 1. Either factored form is correct, as long as we realize that that 2 is going to be a double root in our graph. So now we're ready to sketch a graph. Let's see, I think I'm going to count by halves here. I'm going to make this be negative 1. Let that be negative 1/2. And then my other 0 would be over here at 2. And let's see, I had a y-intercept of 4. So I'll mark that point right there. That's 4. And we know that our graph is opening up. I need to keep in mind that 2, that's my double root. So my graph is going to start at positive infinity, come down through negative 1, back up through 1/2. Let me try that again. Back up through 1/2, through the y-intercept of 4. It's going to come down to 2, but remember that's our double root. And so we're going to turn around and go back up. And that gives us the graph of this polynomial.